All right, let's dive right in. We are talking about something huge today, a brand new look at the cosmos that suggests our entire understanding of the universe might have a fundamental crack in it. This could literally change everything. For decades, we've had this bedrock model of cosmology, and it has worked incredibly well. But what happens when new, unbelievably precise measurements start telling us that maybe, just maybe, that model is incomplete, or, dare I say it, maybe even wrong? And look, that isn't just wild speculation. That quote, that comes directly from the team of scientists behind this new data. The challenge to our standard model of the universe, what we call lambda CDM, is very real, and the evidence is starting to pile up. So, to really get a grip on what's happening here, we first need to meet the incredible instrument that's making all these cosmic waves. Say hello to DESI, the Dark Energy Spectroscopic Instrument. It's sitting up on a mountaintop in Arizona, and it is by far our newest and most powerful cosmic detective. It was built for pretty much one reason: to figure out the secrets of dark energy. So how does it work? Well, check out this number, 5,000. That's how many tiny robotic eyes DESI uses to stare at the sky. Each one is an optical fiber that can whip around and lock onto a distant galaxy in just a few seconds. It's this incredible robotic ballet happening night after night. And its mission? Oh, it's just, to create the largest, most detailed 3D map of the universe ever. Over its 5-year run, DESI is going to pinpoint the locations of over 40 million galaxies and these super bright objects called quasars. The sheer scale of this thing is just hard to wrap your head around. Okay, so DESI is building this incredible map. But how does that actually tell us anything about the universe's expansion? Well, the trick is to listen for these echoes. Faint, ancient echoes, left over from the Big Bang itself. All right, get ready for a bit of a mouthful: baryon acoustic oscillations, or BAO for short. Now, I know, it sounds super complicated, but the idea behind it is actually kind of beautiful and simple. Think of it as a cosmic ruler, a standard unit of measurement that's the same size everywhere in the universe. So where did this giant ruler even come from? Well, you have to picture the very early universe. It wasn't empty space and stars. It was this incredibly hot, dense soup. Sound waves rippled out through this plasma, pushing matter out in these giant bubbles. And then, as the universe expanded and cooled, those bubbles just froze in place. They left behind a pattern, a specific distance where galaxies were just a little bit more likely to form. And just how big is this ruler? Get this, it's about 150 megaparsecs, which works out to a mind-boggling 500 million light-years across. So by measuring the apparent size of this ruler between millions of galaxies across cosmic time, DESI can map the entire expansion history of the universe with unbelievable precision. Okay, so we've got our tool, DESI. We've got our method, this cosmic ruler. So now we get to the heart of it, the evidence. This is where things start to get really, really interesting and clash with what we thought we knew. So here it is, the big showdown. On one side, you have our standard model. The idea here is that dark energy, this mysterious force pushing everything apart, is a constant. It's always been the same, it always will be. It gives us a pretty predictable future. But DESI's data is whispering a different story. It's hinting that maybe dark energy is evolving, weakening, almost like it's thawing out over billions of years. Right. So in cosmology, there's this little letter they use to describe this, W. It's called the equation of state. And in our standard, comfortable model of the universe, W is always, and I mean always, equal to -1. Period. End of story. It's supposed to be a fundamental constant of nature. So think of it like a map. Our standard model points to one very specific spot on that map. It's like a big red X marks the spot. This is what the answer should be, according to everything we've understood for decades. But here's the bombshell. The new measurements from DESI, especially when you combine them with data from other big cosmic surveys, they don't land on the X. They don't even land that close. They point to a totally different part of the map. A part of the map where dark energy is, well, not constant at all. And this isn't just a tiny miss, In science, we use this term sigma to talk about how sure we are that something isn't just a random fluke. The gold standard, the we found it moment, is 5 sigma. So when you see DSI combined with certain supernova datasets hitting 3.9 sigma, whoa, that is not a discovery yet, but it is science speak for, hey everyone, you really need to pay attention to this, seriously. So, okay, let's just take a breath. What in the cosmos does this actually mean? If these hints are pointing to something real, what does that imply for the future of everything? Now, let's be super clear here. A 3.9 sigma result is not a discovery, not yet. Science sets that bar incredibly high for a very good reason. But, and this is a big but, it is without a doubt the strongest hint, the most powerful piece of evidence we have ever seen for new physics beyond our trusty old standard model. This is the story of cosmology being written as we speak. And if this is real, the implications are just wow. It would mean dark energy isn't just some boring property of empty space. It's something dynamic, a field that's changing. And that rips up the final chapter of the universe. That whole endless expansion into a cold, dark nothingness, suddenly that's not a sure thing anymore. The universe could slow down, stop, or even collapse back in on itself in a big crunch. The ultimate fate of everything is suddenly up for grabs again. So where do we go from here? Well, the most amazing part is that all of this whole conversation, is based on just the first year of DESI's data. They've already got the 3-year data in the can and are analyzing it right now. By 2026, the full 5-year survey will be done. We're going to have tripled the data, and that just might be enough to give us a definitive answer, one way or another. So here's the bottom line. It feels like the final chapter of the universe's story is being edited, maybe even completely rewritten right before our eyes. And it leaves us with a pretty profound question, doesn't it? If the ending is about to change, are we ready to read it?